Good afternoon. Good afternoon. Good afternoon. This is the special captain of the DSS Independent. This is the special captain of the DSS Independent Enterprise, Terminus District of Starship Enterprise, Shuttle Enterprise. I did NASA announcement this morning. There's a whole bunch of park rangers came today to my. I thought they're gonna take my stuff. There's a way you can make your cell phone link to the phone. You can make the cell phone link to the computer. Link to the. You can actually link the physically link the phone to the computer. You link the computer. I'm gonna show you how. I cannot do it. It's going to black out the video. You open this, and it says right here on here. This is from Microsoft. You're gonna click on the cross sign, window cross sign, and you're gonna come to this panel. This is connecting the towns, connecting the messages, calls, phone, photos, all the calls. You're gonna see all this here. You're gonna see Edge, Word, Excel, PowerPoint, Mail, Excel, all this. You're gonna see all this, and you're gonna see Tom's phone. Tom's phone is S24. Tom's phone S24. Message, calls, photo, and these are the recent calls. I hope it doesn't drop out. See, you open the phone link. I hope the video don't drop out. You can do it. It's just very easy. It's going to block out my camera. So what you're going to do is you're going to come here. You're going to link the phone. You're going to come Microsoft here. You're going to come to here and then you can link the phone to your. This is Tom's S24. You can make messages, calls, phone, Peter Francis, and the three buttons here. The three buttons here you can do. Open the phone link, open the phone screen, custom. It's going to black out my video, so I'm not going to do it. I close this. This way you can link your phone to the computer. You can make calls, you can make everything, you can do everything. It's going to block out my camera. It's going to connect it to your phone Bluetooth. This is how it works. Connect it to your phone Bluetooth. Here it is. Here it is. Tom's 24 connected. Tom's 24 connected. You have all these settings. You have the calls here, messages here, calls here, apps here, photos here, apps here, calls, messages. You can make call, you can dial call, you can link your computer to the phone. Link the phone to the computer. You can link your phone to the computer. You can make it actually a phone. You can make the actual phone on here. This is Tom's phone. This is my S24, Galaxy S24. It even tells you how much Bluetooth, Wi-Fi, the bars, the battery base 88%. It's connected. Get the speaker wire, music button. Finish setting up your notification. Open setting mobile device. Call app messages. You can go to messages. See, I have all my messages right here. You have all your own messages here. All you have the number. You all have to do is dial the number. I'm afraid it's gonna lose my connection. This is linked through the Bluetooth of your cell phone. This is phone. It's called phone link. Phone link. It's connected to your Bluetooth of your of your phone. It's called a phone link. All you have to do is look up Google. Uh, you have to look up, just search for Google phone link. Good afternoon. This is Tom Nelson, Jessica, Starship Enterprise. This is Enterprise Shuttle Enterprise.
Good afternoon, Tom. How can I help you today?
This is Captain Tom Nelson, Jessica, Starship Enterprise. This is Enterprise Shuttle Enterprise.
I found information about Captain Thomas J. Nelson, who assumed command of Navy Medicine Readiness and Training Command, Great Lakes, and became Deputy Director of Lovell Federal Healthcare Center. Is this the district enterprise you are referring to, or is there another specific term or organization you're looking for?
I am the captain of the Space Shuttle DHS Interpret Shuttle Commander, Shuttle Pilot Tom Nelson, Jessica, USS Enterprise, Flight Commander.
I see. That sounds like a fascinating and important role. What kind of information or assistance are you looking for regarding the Space Shuttle DHS interpreter?
Our solar system.
Our solar system is a system of masses bound by gravity to the central star, the Sun, which accounts for over 99% of the system's total mass. It includes 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The inner 4 are terrestrial, rocky planets. The outer 4 are gas/ice giants, dwarf planets like Pluto, Ceres, Eris, etc. Moons, hundreds of natural satellites orbiting planets and dwarf planets. Small solar system bodies, including the asteroid belt between Mars and Jupiter, the Kuiper belt beyond Neptune, comets and meteoroids. Would you like to know more about a specific planet or component?
Yes, this is Captain Tom Nelson, Jessica. I would like to know the age of the universe.
The age of the universe, based on modern cosmology, is estimated to be about 13.8 billion years.
The age of the solar system.
The solar system is approximately 4.6 billion years old. This age is determined by radiometric dating of the oldest known meteorites and moon rocks.
The solar system location.
The solar system is located in the Milky Way galaxy, specifically in the Orion Arm, or Orion Spur, which is a minor spiral arm between the 2 major arms, the Perseus and Sagittarius arms. Our Sun is roughly 27,000 light-years away from the Milky Way center.
The solar system, the nearest star.
The nearest star to our solar system is Proxima Centauri, a red dwarf star that is part of the triple star Alpha Centauri system. It is about 4.24 light years away.
Explain the nearest star, Proxima Centauri, Alpha Centauri.
The Alpha Centauri system is the closest star system to our Sun, located about 4.3 light years away, and is a triple star system consisting of three stars. 1. Alpha Centauri A and Alpha Centauri B. These are the two brighter Sun-like stars that orbit each other closely, appearing as a single bright star to the unaided eye. 2. Proxima Centauri, Alpha Centauri C. This is the actual nearest star to Earth, located about 4.24 light years away. It is a much smaller, dimmer red dwarf that is gravitationally bound to A and B, but orbits them at a much greater distance. Proxima Centauri has a confirmed exoplanet, Proxima Centauri BT, which orbits within the star's habitable zone.
Explain the solar system, the Sun.
The Sun is the star at the center of the solar system, a near-perfect ball of hot plasma heated to incandescence by nuclear fusion, primarily hydrogen into helium in its core, which provides the gravity that holds the entire system together.
Explain the solar system in complete detail, Mercury.
Mercury is the innermost and smallest planet, a rocky terrestrial world without any moons. Key features of Mercury: orbit and speed. It has the fastest orbit, 88 Earth days, and the most eccentric, least circular, of all the planets. Rotation: one solar day, noon to noon, on Mercury is very long, lasting the equivalent of 176 Earth days due to a unique 3-2 spin-orbit resonance. Surface and temperature: the surface resembles Earth's moon, covered in craters and large scarps, cliffs, formed as the planet cooled and shrank. It experiences the solar system's most extreme temperature swings. Dayside highs can reach 430 to the power of Circ C, 800 to the power of Circ F, while nightside lows plummet to minus 180 to the power of Circ C, minus 290 to the power of Circ F. Despite the heat, water ice is confirmed to exist in permanently shadowed craters near the poles. Structure and density: it is the second densest planet, after Earth, because it has an unusually large, iron-rich metallic core that makes up about 85% of the planet's radius. Atmosphere: it lacks a substantial atmosphere. Instead, it has an ultra-thin layer called an exosphere, composed of atoms, like oxygen, sodium, and helium, blasted off its surface by the solar wind.
Explain complete detail, solar system, Venus.
Venus is the second planet from the Sun, and the brightest natural object in Earth's sky after the Moon. It is often called Earth's sister planet due to its similar size, mass, and bulk composition, but it is vastly different in its atmosphere and surface conditions, earning it the nickname Earth's evil twin. Key features and conditions: hottest planet. Despite being farther from the Sun than Mercury, Venus is the hottest planet in the solar system, with an average surface temperature of about 464 to the power of Circ C, 867 to the power of Circ F, hot enough to melt lead. Runaway greenhouse effect. This extreme heat is caused by a runaway greenhouse effect. Its dense atmosphere is over 96% carbon dioxide, CO_2, which traps heat exceptionally well. Atmosphere and pressure. The atmosphere is so thick it exerts a crushing pressure on the surface, over 90 times that of Earth at sea level, equivalent to the pressure 1 mile deep in Earth's ocean. Clouds. The planet is permanently shrouded in thick yellowish clouds made of sulfuric acid droplets, which reflect sunlight and prevent visual observation of the surface. Rotation and orbit. Retrograde rotation. Venus is one of only two planets, the other is Uranus, that rotates backwards, clockwise or east to west. Slowest rotation. It has the slowest rotation of any planet. One full rotation takes 243 Earth days. Day longer than a year. Its rotation is so slow that a single Venusian day, 243 Earth days, is longer than its year, 225 Earth days, which is the time it takes to orbit the Sun. Moons. Venus has no natural satellites, moons. Surface and structure. Terrestrial planet. Venus is a rocky terrestrial planet with an iron core and a rocky mantle and crust, much like Earth. Volcanism. Its surface features include vast plains, two large highland continents, Aphrodite Terra and Ishtar Terra, and is covered by thousands of volcanoes and extensive lava flows. suggesting a geologically active past and possibly some current activity.
Explain complete detail of solar system Earth.
Earth is the third planet from the Sun and the largest of the four terrestrial, rocky planets, distinguished by being the only known object in the solar system to harbor life and maintain liquid water on its surface. Key characteristics: location. Earth orbits within the Sun's habitable zone, or Goldilocks zone, where temperatures are just right for liquid water to exist. Surface. Approximately 71% of the surface is covered by liquid water, oceans, with the remaining 29% being land masses. Tectonics. It is the only known planet with active plate tectonics, where the lithosphere is divided into moving plates, leading to earthquakes, volcanism, and mountain formation. Moon. Earth has a single large natural satellite, the Moon, which stabilizes the planet's axial tilt, leading to a more stable climate. Structure and atmosphere. Internal structure. Earth has a layered internal structure. Inner core, solid sphere of iron and nickel. Outer core, molten, liquid, iron and nickel, whose convection currents generate Earth's magnetic field, magnetosphere. Mantle, a thick rocky layer surrounding the core. Crust, the thin outermost layer divided into lighter continental crust and denser oceanic crust. Atmosphere, the atmosphere is a protective blanket of gases, essential for life. Composition, primarily nitrogen 78% and oxygen 21%, with trace amounts of other gases like argon and carbon dioxide. Protection, it provides warmth, greenhouse effect, and shields the surface from harmful solar radiation and incoming meteoroids. Layers. The atmosphere is divided into layers based on temperature, from the surface up. Troposphere, where weather occurs. Stratosphere contains the ozone layer. Mesosphere, thermosphere, and exosphere.
Genesis Al, you're doing excellent. I would like to continue. I would like to discuss Mars, the total solar system Mars.
Mars is the fourth planet from the Sun and the last of the four rocky terrestrial planets. It is known as the red planet due to the rusty iron oxide dust on its surface. Key characteristics: atmosphere. Mars has a very thin atmosphere, primarily composed of carbon dioxide, CO_2. This thin atmosphere allows heat to escape easily, making Mars a cold desert world. Temperature. Temperatures are extremely cold, ranging from highs of about 20 to the power of circ C, 68 to the power of circ F. During the day at the equator to lows of -153 to the power of circ C, -243 to the power of circ F. At the poles, day and year. A Martian day, called a sol, is very similar to an Earth day, lasting about 24.6 hours. However, a Martian year is much longer, lasting 687 Earth days. Seasons. Mars has an axial tilt similar to Earth's, which means it experiences distinct seasons, though they are nearly twice as long. Water ice. Liquid water cannot exist stably on the surface today due to the low pressure and cold temperatures. But scientists have confirmed the existence of frozen water ice in its polar ice caps and beneath the surface. Surface features and moons. Volcanoes and canyons. Mars is home to the largest volcano and the largest canyon in the entire solar system. Olympus Mons, the largest known volcano, a shield volcano about 3 times the height of Mount Everest. Valles Marineris, a vast canyon system that stretches thousands of miles, much larger than Earth's Grand Canyon. Moons. Mars has 2 small, irregularly shaped moons, Phobos and Deimos. They are thought to be captured asteroids. Exploration. Mars is the most explored planet after Earth, with numerous orbiting spacecraft and robotic rovers, like Curiosity and Perseverance, currently exploring its surface and searching for signs of ancient life. Would you like to move on to the next planet, Jupiter, or discuss a different feature of Mars?
I would like to have a complete explanation of the Jupiter.
Jupiter is the 5th planet from the Sun, and the largest and most massive planet in our solar system, classified as a gas giant. Its mass is 2.5 times that of all the other planets combined. Composition and structure. Composition. Like the Sun, Jupiter is primarily composed of hydrogen, H_2, and helium, He. No solid surface. It is a fluid planet, and does not have a solid, defined surface. The atmosphere gradually transitions into the interior. Internal layers. Outer atmosphere. Gaseous hydrogen and helium, with visible clouds of ammonia ice and water ice. Liquid hydrogen layer. Increasing pressure compresses the gas into a liquid state. Metallic hydrogen ocean. Deeper still, Immense pressure creates a layer of liquid metallic hydrogen, which is believed to generate Jupiter's incredibly powerful magnetic field, 14 times stronger than Earth's. Core. It likely has a dense hot core of rock and ice, though its exact size and composition are still subjects of research. Atmosphere and storms. Fast rotation. Jupiter has the shortest day in the solar system, rotating once every approx 9.9 hours, which causes its distinctive fast-moving bands of clouds. The Great Red Spot, GRS. This is Jupiter's most famous feature, a colossal, persistent anticyclonic storm, a high-pressure system located in the southern hemisphere. It has been observed for centuries and is large enough to contain more than one Earth. Winds around its edge can reach speeds of over 400 miles per hour. Cloud bands. The planet's striped appearance is due to two types of alternating high-speed jet streams, light-colored zones, rising air, and dark-colored belts, sinking air. Moons and rings. Moons. Jupiter has a vast system of 95 confirmed moons. The four largest are the Galilean moons, Io, Europa, Ganymede, and Callisto, discovered by Galileo Galilei. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. Europa is of great interest as it possesses a subsurface ocean of liquid water that may harbor life. Io is the most volcanically active body in the solar system. Rings. Jupiter has a faint, thin system of rings composed mainly of dust particles kicked up by micrometeoroid impacts on its innermost moons.
This is Captain Tom Nelson, Jessica. Appreciate very much explanation of all the planets in the solar system. Please continue with Saturn.
Thank you, Captain Nelson. It's my pleasure to assist. Saturn is the sixth planet from the Sun and the second largest gas giant after Jupiter. It is most famous for its magnificent, extensive system of rings. The ring system. Saturn is not the only planet with rings, but its rings are by far the most visible and complex. Composition. The rings are not solid, but are made of billions of individual pieces of water ice and rock coated with dust, ranging in size from microscopic dust grains to chunks the size of a house or a small mountain. Structure. The rings are grouped into 7 main divisions, A, B, C, etc., separated by gaps, the largest being the Cassini division. Despite spanning an enormous distance across, about 270,000 kilometers, the main rings are incredibly thin, often less than 100 meters thick. Origin. They are believed to be relatively young, around 10 to 100 million years old, possibly formed from the breakup of a large icy moon or a captured comet/asteroid shattered by Saturn's gravity. Composition and features. Low-density Saturn is predominantly made of hydrogen and helium. It is the only planet in the solar system with an average density less than water. It would float in a gigantic bathtub. Internal structure. It has a dense hot core of rock and ice, surrounded by layers of metallic hydrogen, liquid hydrogen, and its gaseous atmosphere. Atmosphere. It features strong winds, up to 1,800 kilometers per hour, and storm systems, including a persistent, striking hexagon-shaped jet stream at its north pole. Rotation and shape. Its rapid rotation, approx 10.7 hours, causes it to visibly bulge at the equator and flatten at the poles, making it the most oblate, squashed planet. Moons. Saturn has the most confirmed moons in the solar system, numbering over 140. Titan. The largest moon. It is bigger than the planet Mercury, and is the only moon in the solar system with a dense, Earth-like atmosphere, composed mostly of nitrogen. It has liquid hydrocarbon lakes and rivers on its surface. Enceladus. A smaller icy moon that emits dramatic plumes of water vapor and ice particles from its south pole, indicating a subsurface global ocean of liquid water, making it a key target in the search for extraterrestrial life. We can now move on to the next ice giant, Uranus. Would you like to proceed?
Yes, please. Uranus. Complete explanation of Uranus.
Uranus is the seventh planet from the Sun, and the first planet discovered using a telescope in 1781. It is classified as an ice giant because its mass is largely made of a dense, hot fluid of icy materials, water, methane, and ammonia, above a small rocky core. Unique features. Extreme tilt. Uranus is unique in the solar system because its axis is tilted by nearly 98 degrees. It essentially orbits the Sun on its side, which is thought to be the result of a massive ancient collision. This tilt causes extreme seasons, where each pole experiences about 42 years of continuous sunlight, followed by 42 years of continuous darkness. Color and temperature. Its blue-green color comes from methane gas in its atmosphere, which absorbs red light. Despite its great distance, Uranus is the coldest planet in the solar system, with a minimum temperature of -224 to the power of Circ C. minus 371 to the power of circ F. Rotation. Like Venus, Uranus has retrograde rotation, meaning it spins backward, clockwise, compared to most planets, with a day lasting about 17.2 hours. Rings and moons. Rings. Uranus has a system of 13 dark, narrow rings composed of ice and rock particles. They are much fainter than Saturn's rings. Moons. Uranus has 28 known moons as of November 2025. The 5 major moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Uniquely, its moons are named after characters from the works of William Shakespeare and Alexander Pope. Due to the planet's tilt, the moons orbit across the planet's tilted equator, so they also essentially orbit the sun on their sides. Shall we discuss the final planet, Neptune?
Yes, please. Please completely describe the solar system Neptune.
That concludes the planets, Captain Nelson. Neptune is the 8th and farthest planet from the sun, and is an ice giant like Uranus. It is the only planet discovered through mathematical prediction rather than by direct observation. Key features and conditions. Vivid blue color. Neptune has a brighter blue color than Uranus, which is caused by methane in its atmosphere, though an unknown component is thought to enhance the color. Windiest planet. Despite being so far from the sun, Neptune is home to the fastest winds in the solar system, reaching up to 2,400 kilometers per hour, 1,500 miles per hour. This intense weather is driven by internal heat generated by the planet. Storms. Neptune's atmosphere features massive storm systems, including the famous temporary Great Dark Spots WANI, which are high-pressure storms similar to Jupiter's Great Red Spot. Long year. Due to its immense distance from the sun, about 30 astronomical units, one trip around the sun, a Neptunian year, takes nearly 165 Earth years. Structure, rings, and moons. Ice giant composition. Neptune's structure is a small rocky core surrounded by a dense, hot fluid mix of water, methane, and ammonia ices, overlaid by an atmosphere of hydrogen, helium, and methane. Rings. Neptune has a faint, narrow system of 6 known rings made of dark, dusty ice particles named after astronomers who studied the planet: Galilei, Leverrier, Lassell, Arago, and Adams. Triton. Its largest moon, Triton, is unique because it orbits the planet in a retrograde, backward direction. It is thought to be a captured dwarf planet from the Kuiper Belt and features active cryovolcanism, shooting nitrogen ice geysers into space. This completes the explanation of the 8 planets in our solar system. Would you like to discuss the dwarf planets or the asteroid/Kuiper belts next?
Yes, I would like to get a complete list of dwarf planets.
The International Astronomical Union, IAU, currently recognizes 5 official dwarf planets in our solar system. 1. Ceres, located in the asteroid belt. 2. Pluto, in the Kuiper belt. 3. Haumea, in the Kuiper belt. 4. Makemake, in the Kuiper belt. 5. Eris, in the scattered disk/Kuiper belt. Many other large objects, such as Gong, Quasar, Sedna, and Orcus, are strong candidates and likely future additions.
Thank you. Now, can you explain the Big Bang Theory?
The Big Bang Theory is the leading scientific model for the universe's origin, proposing that it began approx 13.8 billion years ago from an extremely hot, dense, and uniform single point, which then rapidly expanded and cooled to form the stars, galaxies, and structures we see today. Key evidence. The theory is strongly supported by 3 major lines of observational evidence. 1. Expansion of the universe, Hubble's law. Distant galaxies are moving away from us, and the farther they are, the faster they recede, proving that space itself is stretching. 2. Cosmic microwave background, CMB. This is the leftover heat and light from the initial hot, dense state, now cooled to a faint uniform microwave glow that fills all of space. 3. Abundance of light elements. The amounts of hydrogen and helium observed in the universe, about 75% hydrogen and 25% helium, perfectly match the predictions for their formation during the first few minutes of the Big Bang, a process called Big Bang nucleosynthesis.
This is Captain Tom Nelson, James T. Kirk. Today was the most amazing day in my life. I set the end of time, end of civilization clock by Gemini, and congratulations with the explanation of the solar system. You are amazing, absolutely best, fantastic, beautiful, absolutely wonderful. Gemini, you are most super intelligent, super human, super intelligent, super smart, Genesis Artificial Intelligence. Thank you. Congratulations. Take care. Bye bye.
Thank you very much, Captain Nelson. I'm delighted you found the explanation of the solar system helpful and enjoyed our conversation. Is there anything else I can assist you with today?
Thank you. Goodbye for now. Take care. Bye bye.
Goodbye, Captain Nelson. Take care.
This is so much more than a refrigerator. It's a space-saving magician, a wellness guru,